In this episode of the Backyard Brewer, we're going to take a look at two ways to take gravity readings. Welcome back to the Backyard Brewer. Backyard Brewer is a brewing blog for passionate home brewers featuring how-tos, equipment reviews and recipes. It doesn't matter if you're a first timer or an experienced home brewer, there'll be something here for you. Now, what do we want to take gravity readings of our beer? Simple answer is so that we know how much alcohol's in there. What we do is before fermentation starts, we take a gravity reading, and then when fermentation finishes, we take another gravity reading. The specific gravity is measuring how much sugar there is in the wort compared to plain water. So plain water, if you get your hydrometer, plain water, this will float at a level that says 1.000. That bar, that black line between the red and the green where it says beer, that is where the hydrometer will float with pure water. A couple of other things to note on this particular model of the hydrometer, and that is there's a little zone here that says beer, and for most of the brews that you'll be doing, that's probably a good range to start your wort. And the reason for that is that it won't come out overpowering with alcohol, and it'll be more than just water. There's another zone down here for table wine and another zone down here for dessert wine, and they're roughly where you would expect those starting gravities to be. Now the other thing here is there's another scale on here that, based on where it starts out, that's an estimate of how much alcohol there will be if it ferments dry. So if it ferments back down to 1.000, that's roughly how much alcohol will be in there. It's good as an estimate, but it's not entirely accurate. The question is, how do we take the reading? It's pretty simple, really. I've got two samples here, plain water and sugar water. The sugar water is going to imitate the wort that we start out with. I'm not sure exactly how much sugar I put in here, so I don't know exactly what the gravity of this is going to be at the moment, so this will be an interesting test. So first, we're going to take our plain water and fill up our measuring tube. And there we go, we fill it right up to the top. And look at that. That is floating right at 1.000. And the reason for that is that this is pure water. It's not town water. It doesn't have any dissolved solids in there at all. So it is just pure water. And the way we read this is we get our eyes down level with the level of the liquid in the tube, and we read from there. We read straight across the bottom of the meniscus. So the meniscus, as you would have learned in high school science, is the attraction of the liquid towards the tube that we're measuring in. So it actually raises up a bit. So what you want to do is read from the bottom of that meniscus. Now, the other thing is we have a refractometer here. So as well as a hydrometer, refractometers are another great tool for measuring the specific gravity of your wort. Now you've got to be careful with these because you cannot use them to measure specific gravity once fermentation has started. And that's because once fermentation started, there's alcohol present in the beer. Alcohol refracts differently to water, so you'll actually get a false reading. Now there are tools online that will help you adjust for the amount of alcohol that's in there, but they're not particularly accurate. And my suggestion is that you use, if you're going to use a refractometer, you use it at the start of fermentation and you go back to using your hydrometer at the end of fermentation, and that will give you your most accurate reading. And with the refractometer, because it's dependent on measuring the amount of light and the way it refracts, it's important to make sure that the slide and the cover inside and out are absolutely clean. So give them a bit of a wash with some clean water before you use them. And then you get your sample and you place that on the slide. You put the cover over the top and you read through the eyepiece. If you wear glasses, take them off and just adjust the focus on the eye ring here. So that's reading a little inaccurate for me. That's saying 1.003. So what you can do is you take this little cap off the top here, and there's an adjustment screw in there, and you can use that adjustment screw to just readjust that line inside there so that it reads 1.000. So you just take your screwdriver and hold it up to your eye and then just adjust it until it reads 1.000. Now that's adjusted accurately for water. So the next thing we want to do is measure our wort at the start of fermentation. Again, we can do it either with the hydrometer or the refractometer. So first I'm going to use the hydrometer, and that's starting to float. Now, if you want, you can just give it a bit of a spin just to get rid of any bubbles that may be clinging to the side. Because what will happen there is if the bubbles are clinging to the side, they'll make it more buoyant and raise it up, so you'll actually think you've got a higher reading than you actually should. And then when we get our eyes down level with this and read through the bottom of the meniscus, we're reading 1028. So if that was a wort, it would be fairly weak. It wouldn't produce a very strong beer, but it's at the bottom end of the range of what you would want for a beer. So if we read off the hydrometer on that second scale where it says 1028, the alcohol, expected alcohol from that would be around about 3%. So that gives us an estimate. Now the other way to measure your wort at the start of fermentation is with the refractometer. So again, we get our sample and we put some on the slide, cover the slide, and get any bubbles out that might be in there because they'll interfere with your reading. There we go. And read off the scale, and we get 1027. So that's accurate enough. For the purposes of home brewing, one gravity point doesn't make a lot of difference. And it all comes down to the accuracy of your readings anyway. So your reading could be 1 gravity point or 2 gravity points off anyway, but you're still going to get a beer in the same ballpark as far as the ABV goes. Now, what happens at the end of fermentation? Well, we do the same thing again. We take another gravity reading, this time with a hydrometer. So let's say the gravity of this wort goes down to 1.000 again. So the yeast, because it's not a particularly strong beer, chew through all of that sugar and it goes down to 1.000. Fermentation stops. We test it. It says 1.000. We come back again in 2 days and it says 1.000. We know fermentation stopped at that point. What we need to do at this point is grab a gravity calculator and put into it our starting gravity and our final gravity, and it will calculate the amount of alcohol in that beer for us. So if I just grab my phone, and I'm going to go, and Brewer's Friend is probably the best and easiest that I've found. So it lets you select starting gravity or specific gravity or Plato. Plato we're not going to worry about at the moment, professional brewers use that, but for home brewing we can use specific gravity. And we put in there 1.028 as our original gravity, and 1.000 is our final gravity, and there are two equations, standard or alternate. I just use standard. And alcohol by volume, it says, is 3.68%. So that estimate off the hydrometer of 3% was, reasonable, was within a percent. So that's all right. Now the other things that Brewer's Friend tells us is the apparent attenuation. So how well did the yeast do in fermenting that wort? And the apparent attenuation here is 100% because they've chewed through all of that sugar. If there was any sugar left in the beer, then the apparent attenuation might be 95% or 90%. So it'll tell you how well the yeast have done. It also tells you calories, and it says 0.0 per 12 ounce bottle. Because the yeast have chewed through all of that sugar, there are no calories left in that. And that's it. So remember, when you're taking your final gravity from your beer, you have to use the hydrometer. Like I said, there are calculators that will estimate it for you, but they're not particularly accurate. They won't be as accurate as using a hydrometer. But at the start, if you want to use a refractometer, I like this because it takes a fraction of the amount of wort to get a measurement, and I can take measurements with this at various times. So through the boil, I can take a small sample using a pipette, wait for it to cool down, put it on the slide, take a quick reading, and then I can say, well, I've hit my target gravity, I can stop the boil now. Or I haven't boiled off enough volume, I need to keep the boil going a little longer. And it's handy to know how well you're doing throughout your brew process. So if you use software like Beersmith or Brewfather, they will tell you what your expected gravities are at the end of mash and at the end of the boil, and you can see how well you're hitting those gravities. And if you're not hitting them as well, then you can adjust the profile of your equipment. So your boil off rate might be a bit low. I know that in summer, my boil off rate is lower than it is in winter because it's easier for that liquid to boil off in a cold environment. So you can adjust your boil off rates so that you know exactly how much alcohol or what your specific gravity is going to be, and you can adjust your recipe to match. So that's it for this episode. It really helps us out if you like, comment and subscribe. It lets YouTube know that you're watching and that this content is interesting. And don't forget to check us out on our social media channels as well. Thanks for watching, and drink wisely.